we are restarting the final section in our statistics OER course on how to use the normal distribution. We will do some problems using just the empirical rule. Then we will do some problems that will have more accurate answers using technology. In reference for this section, you can find this section at the Introductory Statistics book by OpenStax in section 6.2, using the normal distribution, and in the Lumen Introductory Statistics with Corequisite course, and again in module 6, Introduction to Using the Normal Distribution, Probabilities, and the Summary. So we want to assume that we want to discuss what's going on when we have a variable that is the wait time at the drive-thru of a coffee shop, and it's a variable that is normally distributed with a mean of 1 minute and 30 seconds and a standard deviation of 20 seconds. So the variable that is a wait time will be expressed in the form of minutes, seconds, and it is normally distributed with a mean of 1 minute 30 seconds and a standard deviation of 20 seconds. So when you sketch the distribution, you want to make sure that you label the axis. So this will be wait time in the form of minutes and seconds. And the mean is 1 minute and 30 seconds, and it happens to be the median of the distribution, so it's in the middle, and also the mode, so it's under the highest peak of the curve. And then we do 3 tick marks to the right for the 3 standard deviations to the right, and 3 tick marks to the left for the 3 standard deviations to the left. That include 99.7% of the data of the normal distribution. So these values are, every tick mark is 1 standard deviation. So 1 minute 30 seconds plus 20 seconds will be 1 minute 50 seconds for the first tick mark to the right, 2 minutes 10 seconds for the second tick mark to the right, and 2 minutes 30 seconds for the last tick mark on the right. Going to the left, we will be subtracting. So 1 minute 30 seconds minus 20 seconds, 1 minute 10 seconds, 0 minutes 50 seconds, and 0 minutes 30 seconds. If we go by 20 seconds to the left. So for every question, you will be asked to sketch the distribution and find the probability. So we will use the empirical rule for this. We will not use technology. Remember the empirical rule. Within 1 standard deviation lies 68% of your data. Within 2 standard deviations lies 95% of your data. And within 3 standard deviations lies 99.7% of your data. So they are asking you to find the probability that X will be between 1 minute and 10 seconds and 1 minute and 50 seconds. So if I sketch my curve, remember to label wait time. The units are minutes and seconds. This is 130. Draw your 3 tick marks to the left and to the right. They go up by 20, so 150, 210, 230. Going to the left, 110, 050, 030. And they are asking us for the probability that X will be between 110 and 150. So this area. Well, a 110 is 1 standard deviation below the mean. 150 is 1 standard deviation above the mean. The data that is between those two values is 68% of the data. Therefore, the probability will be 0.68. For the next one, we will sketch again. We want the probability of x being between 130 and 150. So I sketched all the distributions just so that I don't waste time during the video to do so. Make sure you always have a sketch of the distribution for every problem you are answering. So from between 130 and 150, that will be from the mean to 1 standard deviation above the mean. And this distance is half of the quantity from -1 standard deviation to +1 standard deviation. And half of 68 will be 34%. Remember that the normal distribution is symmetric. So symmetric means whatever happening on the right of the mean will happen to the left of the mean. So that answer here will be 0.34. From 0.50 to 130 will be 2 standard deviations below the mean to exactly the mean. So we have approximately 95% of the data that goes from -2 standard deviations to +2 standard deviations. And this is exactly half of that. It is from -2 to 0 to the mean. So half of 95 will be 47.5%. And therefore the answer here will be 0.475. To go from 0 minutes and 50 seconds to 2 minutes and 10 seconds, this is 2 standard deviations below the mean to 2 standard deviations above the mean. And from the empirical rule, we know that within 2 standard deviations lie 95% of the data. So we know that this value will be 0.95. Less than 1 minute and 50 seconds. 1 minute and 50 seconds is 1 standard deviation above the mean. So we know that from the mean to 1 standard deviation above the mean was 34%. We answered that question earlier. And then from the mean to the end of the distribution to the left will be just half of the data, because the mean happens to also be the median. And the median has half of the data less than or equal to its value. So that answer is 50% plus 34%. That will be 84% or 0.84. Let's sketch the distributions for the rest of the questions as well. So now that we have sketched our curves, we can answer the rest of the questions. What's the probability x is less than 130? Well, 130 is the mean. The mean is also the median. So less than 130 will be half of the data. So the probability will be 0.5. What's the probability it is less than 110? So 1 minute and 10 seconds is 1 standard deviation below the mean. Less than that will be the data to the left. And we know that the data to the right is 50% to the right of the mean. The data between 1 standard deviation below the mean and the mean is 34%. And the data to the left of 1 standard deviation below the mean would be either 1 minus the 50% minus the 34%, or it will be the half of the left half. So 50% of the left half minus 34%. So in both cases, the answer is 16%, so 0.16 is the answer to that. How about x being greater than 1 minute and 50 seconds? This is the same thing. We are one standard deviation above the mean, and we are looking for greater values. And again, the right side of the mean is 50%. The left side of the mean is also 50. And the distance from the mean to one standard deviation above the mean is 34%. So again, you can think of this as 50% minus 34%, or the whole curve minus the 84% that is below the 150, and therefore that answer will also be 0.16. How about greater than 2.10? 2.10 is 2 standard deviations above the mean, and we are looking for the little tail to the right of the curve. If you remember, the empirical rule says that 95% of the data will be within 2 standard deviations from the mean, and that means that 5% of the data will be below or above those two values. So below the z-score of -2 and above the z-score of +2. So if 5% consists of the yellow shaded tail plus the green shaded tail, and this distribution is symmetric, the yellow shaded tail that contains the values that are 2 standard deviations above the mean will be 5% divided by 2. And that will be 2.5%, or in decimal form, 0.025. Finally, what's the probability the value of the variable will be above 1.30, 1 minute and 30 seconds, and that is the mean. So what's the probability a value of the variable will be above the mean? The mean is the median, and half of the data is above the mean, and half of the data is below the mean. So 0.5 will be the answer.